Hi, I'm Dr. McFerrin from DM Explains. In this video, I want to help you get started with Simulink. Simulink is a block diagram programming software which operates in conjunction with MATLAB. It can be used to model complex systems, do all sorts of interesting math operations in a lot of control systems applications, which is kind of my thing. From within MATLAB, I can open up Simulink one of two ways. I can either click this Simulink icon in the Home tab, or I can just type Simulink directly into the command window. When I do so, I get this screen, and I can choose a blank model to work with. I'm actually going to pull up another model, so that way you get a feel for some of the components that are within a model. So I'm going to open up this one. This one is called Lecture 28 Sim. There's a lot of information going on here, but there are two basic components of a Simulink model. There are blocks, which are what all of these block-looking things are. Some of them are round, some of them are triangular, some of them are squarish, but these are what we call blocks. And then there are lines, which are the interconnections between those blocks. This whole file is called a model file, and it has the file type .slx. Let's dig a little deeper into building something. So what I'm going to do is I'm going to go ahead and start with a blank model. I'll close this one. And I want to show you how I can add things to my model. So the first thing I want to do is I want to go right here to the library browser. So if I click that, and what I'll see is that there's a bunch of different options here. Depending on the toolboxes you have installed, you might have other block sets here, but the Simulink one is the one I'm going to look for. There are a couple of ways to navigate to something that I want. The first is if I know what I'm looking for, I may search for it in this little search bar up here, or I can click through and find what I'm looking for. So I'm going to start with finding a source, and in fact I'm going to choose a step input source. So let's do that. And I've now got a nice step block. One thing I also want to do is display in more updated versions of MATLAB, it will hide the automatic names, but in order to help you learn, I want to show them, so I'm going to select to keep those automatic names on. The next thing I want is a transfer function, which is in the continuous block set. And if I take a look here, it's right here. I'm going to drop that in. It's going to start with 1 over s plus 1. And then the last thing I need is a sink or a place for the signal to go. I'm going to choose as a sink a scope. The next thing I'm doing is I'm just clicking and dragging to connect these using my lines. So if I double click on the scope, it's going to show me basically like if I had an oscilloscope or a plot up. And if I double click on the step, you'll see the step time. That's usually the time at which it starts. I'm going to set that to 0, and then I can also set a final value. Those are kind of the big important parameters in a step. So if I want to run this and see what I get on the scope, I can click the little run symbol. And you can see I have this first order step response. I have a first order transfer function. The details of that are maybe something you don't need to know right now, but I just want to get you a feel for what you can do in Simulink. Other parameters that are useful to know how to deal with here are how to change the stop time. Here where it says 10.0, that is the stop time for my simulation. I could change that. I could say make it 5 and run, and if I click on the scope, you'll see that it only goes up to 5 seconds before it stops. I'm going to move that back to 10, and then what I want to do is I want to build up a slightly more complicated file. First thing I'll do is that I will change the transfer function. So in the transfer function, I can choose different coefficients. So this is 5 times s to the 0 for the numerator, and then I've got a 1, a 2, and a 5. So this is going to be s squared plus 2s plus 5. So if I click OK, you'll see, if I expand this a little bit, that now it looks like 5 over s squared plus 2s plus 5. And so what I can do is just run it open loop like this, see what sort of response I get. It turns out I've got a nice sort of underdamped response that does settle out nicely to a step response of 1. All right. Then what I can do is I can also add in more blocks. So what I'm going to do is I'm going to make this a feedback system. So I'm going to delete that line. I'm going to go back to my library browser, and then I want a summer. So if I just type sum up here, this, by the way, is also in math operations. Add also works, but I'll take this sum and slide it in here. I'm going to double click on it, and it's going to give me a list of signs. Straight up and down deal there is telling me that there's nothing on the top, and then I'm going to make it plus minus. And so now I've got a plus and a minus on this summer, which hopefully you can see all right. And then what I'm going to do is I'm going to also add a gain. So let me go ahead and add in a gain. A gain is just a block which I can use to put numbers, or if I prefer, variables from MATLAB in. So let me go ahead and just do this. I'm going to leave it at 1 for now, and I'm going to put in a line there, and then I want to connect this minus sign to the output, and this is what I call a negative feedback system, and connect my step to the plus sign. All right, now if I open up the scope and I click simulate or run, you see I've got a slightly different response than I did before. Instead of settling out at 1, now I'm settling out at 0.5. If I increase this gain, let's say make it 5, let's see what happens. If I click run, what's going to happen is it's going to settle out closer to 1. This is what an example of what I call proportional gain, but I am going to kind of leave it at that for now. What I want to do then is for this gain, I want to make it into a variable. I'll call it K. And now what you'll notice is that it lights up red around here. If you can't see that color, what you should see is a little bit of a fuzzy box around it, and that should let you know that I haven't defined what that variable is. So what I'll do is I'll save the model. I'm going to save it as Simulink how-to.slx. Okay? And then what I'm going to do is I'm going to come into my command window. I'm going to type k is equal to 5 with a semicolon to suppress the output. And now I've stored this variable k equals to 5. So now if I come back to my simulation and I press run, it's going to run as if k was in fact 5. If I change k again, let's say k is equal to 10, we'll see that hopefully changes the output when I run again. And you'll see now I've got a bigger oscillation and it settles out closer to 1. The last thing I want to show you how to do is use the sim command. If I type sim and then a single quote and then the name of my file, which is Simulink how-to, single quote, close parentheses, and hit enter, it's going to go ahead and run the file. It's very difficult to tell that it did because you didn't change any parameters. So let's change it to k equals to 1, put it back to kind of where it was originally, and then I'm going to simulate it again. And then see the response. You can see that this is different, again leveling out at 0.5 like we had earlier. This is kind of a how to get started with Simulink. It turns out that you need a lot more information. If I come back to my library browser, I'm going to kind of just zip through some of the options you have in here. There's some commonly used blocks that may be different. The things that you see here may be different depending on your use here, but I've got continuous. I can add transfer functions, controllers, derivatives, so on. I can do a dashboard to make it look like a nice graphical user interface. I can add discontinuities, discrete time, system routing, logical operations, math operations, lookup tables, syncs, including a terminator and scopes, and in fact probably one of the most useful ones is toWorkspace. So that's actually what I'm going to show you right now. So I'll add toWorkspace down here right below the scope. What I'm going to do is I'm going to click on this and I'm going to change the variable name and I'm going to just call it y, and I'm going to change the format to an array. And what this is going to do when I simulate, so I'll go ahead and sim, is that it saves two variables, y and t out. And so then if I want to, I can go plot t out comma y. And then that plots this in a way that I can label and make useful in a nice report. And so you may see that a lot. The other important stuff to learn may come in later videos, but this is really enough to kind of get you started, especially if you know what blocks you're looking for. Thank you so much for watching this video. I hope that you found it helpful. Until next time, this is Dr. McFerrin, signing off.